Okay, today we're going to talk about pre-Columbian use of metals, especially gold and silver, but other things as well. So there are some really spectacular artifacts from this time, the pre-Columbian cultures before the Spanish invasion. Let's talk about it. All right, so metals were very much appreciated by the pre-Columbian cultures. Gold and silver were in fact considered to be of divine origin. And the main interests were the color, the shine, and the sound were the particular interest of the pre-Columbian people in using these for ornaments and for sacred artifacts. Copper and bronze were later used to produce tools and weapons, but these never replaced the use of stone and obsidian. So, in general, there are 4 stages in the use of metals by cultures worldwide before using iron. You know, once you use iron, then your use of metals really changes. But these are the 4 stages before using iron. So there are 4 stages that are recognized. First is the use of native metals, which these will be hammered or annealed. Things like gold, copper, and silver are found in their native state, and these were the first metals to use because of that. The next thing that happens is that people learn how to smelt ores, in particular, starting with the oxide ores, that is, metals that combine with an oxygen. And then the thing that generally cultures go on to is alloying metals to make things like bronze. And then finally, the final thing before developing the use of iron as a metal is the smelting of sulfide ores. So these contrast with oxide ores. Because oxide ores, the metal is combined with an oxygen, and in sulfide ores, the metal is combined with a sulfur. So we'll go through these. And iron and steel production were never achieved in pre-Columbian Latin America. So we're going to be talking about this evolution. So these are the times of metallurgical development in the world. So there's the Euro-Asiatic, which is over here. Then there's the Great Lakes region. We're not going to spend a lot of time talking about that, but basically this part of the world. And then in Latin America, which is the main topic of our interest, of course. So in the development stages 1, 2, 3, and 4, which we just discussed, that took between 7800 BC to 1200 BC when iron began to be worked. In the Lake Superior, Great Lakes region, the main use of metals was stage 1. They used native metals, especially copper. And then in Latin America, beginning somewhere around 600 BC to the Spanish conquest in the 1500s, they definitely went through stages 1 and 2 and 3, and maybe stage 4, and we'll talk about this. So here's stage 1. This is the use of native metals, and they were the first that were used because these tend to be concentrated at the surface. So here we have a cross section of an ore deposit. So, you know, this is the ground surface, and then here's the deposit. Now, in the atmosphere, there's lots of water and oxygen, and so things get leached, and a lot of other elements are dissolved and carried away, and a lot of metals get oxidized. So this is the zone of oxidation. And so the water table is above here, and below is this nature where you've got this zone of sulfides. And at the very bottom is the primary ore. Now, in the kinds of mining we do today, we're mining this. All of this has been removed, and people worldwide are mining this. But back in 2,000 years ago, people started working these kinds of metals and then these kinds of metal oxides and then on so far down. Now, another thing that happens, rather than just finding these metals in place in exposed, associated with an exposed ore body, is that these metals can be transported by water and deposited in sediments in the sides of streams and such. And these are called placers. So placer deposits are transported of nuggets and other kinds of metals that are concentrated by erosion. And this metal is pure enough to be used, but it's really not very abundant. All right, so here we go to stage 2. All of the native metals have been used, and now the mining has gotten it down into the zone of oxidation. And these oxides and related to them are carbonates are concentrated in this oxidation zone. And these could be mined without too much difficulty because it's not very deep. But then you can't just use them directly like you can with native metals. You have to treat them to remove the oxygen so that you get the metal. So here's an example of the chemical reaction. Cuprite is a metal, is a mineral, copper oxide. And if you combine that with carbon monoxide, which is just CO, it will turn into copper metal and CO2. So here is the chemical equation. Cu2O plus CuO equals copper plus CO2. It's not quite balanced. Actually, this should be 2 CuS. But you can see what's happening. All you have to do is put this ore in an environment where there's a lot of carbon monoxide. So stage 3 is the use of alloys, which bronze is probably the most famous. The Bronze Age is very well known. And this is really the beginning of material science, where humans are starting to take natural materials and combine them in a way. Material science now is a very big field. UTD has a department of material science. This kind of material science that we're talking about here obviously is more primitive, but it was the start. So what is an alloy? An alloy is a substance that's a mixture of 2 or more metals, or of a metal with a non-metallic material. So bronze is an alloy of copper, tin, arsenic, phosphorus, and small amounts of other elements. And bronzes are harder than brasses. Brasses are an alloy just of copper and zinc. So most bronzes are produced by melting the copper and then adding the desired amounts of arsenic, tin, phosphorus, other substances. And most pre-Columbian cultures were in the Bronze Age at the time of the conquest. And as we noted, they had metals and alloys, but they weren't used extensively. Mostly stone artifacts and weapons were being used and we saw what happened, or we'll see what happened when those kinds of weapons were tested against the steel of the Spanish. All right, now stage 4 is getting into this primary ore where the sulfides are. So a sulfide ore has a formula of the metal that could be copper, it could be zinc. We don't know, it doesn't matter, but it's combined with a sulfur. And these sulfides are in the zone that's protected from atmospheric oxygen, because if oxygen and water gets in there, it will replace the sulfur with oxide and we'll have an oxide ore. That's why the oxides are up here. Sulfide zone deposits have a high metal content, but they're harder to mine because they're deeper. So you need ways to keep the water out of the mines. It requires pumping and draining the water. It requires proper ventilation. And the smelting of the sulfide ore, once it's removed from the mine, is more complicated. So you've got to go through 2 steps. With the oxide ore, all you had to do was take that oxide ore and convert it to the metal in the presence of carbon monoxide. But to get the oxide ore, you first have to roast the sulfide in the presence of oxygen in order to get that. So you have to do this first and then this in order to get the metal. So it's a more complicated process to get the metal out of the sulfide ore than just the oxide ore. All right, now this is all related to plate tectonics, and we've already talked about the fact that Latin America is very asymmetric, especially South America, with this very active region in the Andes as a result of subduction of the Pacific plate. And this eastern part is craton, stable platform. And so the ore deposits are related to this subduction. As a result of subduction, you have a lot of igneous activity. There's the volcanoes over here, and the ore deposits are also associated with that process. It's not one-to-one volcanoes are where the ores are, because the volcanoes covering up the ores. Many volcanoes in Latin America are probably built on top of ore deposits, but it won't be until they're eroded that we get to look at those ore deposits. So plate tectonics is very useful for understanding how ore deposits form and where to look for them. So a lot of magmas related to the subduction zone form the mineral deposits. And as a result, the ore deposits in all of the Americas, including North America, are concentrated in the West. So think about the California gold rush. That is, the gold was over here because of plate tectonics. So we'll talk more about plate tectonics and Latin American ore deposits in later lectures. All right, so let's talk about gold. Let's start off with gold. Gold is a metallic chemical element, element 79, and has a symbol AU. And everybody's pretty comfortable with the idea of gold. They just wish they had more of it. So in jewelry, gold's purity is expressed in 24ths or carats, or K. So 24 karat gold is pure gold, 12 karat gold is 50% gold, etc. So 24 karat gold melting point is, this temperature. It's not really that high. It has this incredibly high specific gravity, right? Specific gravity of 19 compared to water with a specific gravity of 1, or just normal everyday continental crustal rocks, which have a specific gravity of about 2.7. This is very, very dense, which is why it's often concentrated in placer deposits. It doesn't get carried easily very far. The gold is actually found very widely distributed in all igneous rocks, but in very low concentrations. And so its recovery from ores and other deposits has been a major preoccupation since ancient times. And the world's gold supply has seen 3 great leaps. The first one was the Spanish conquest of the Americas, and we'll hear more about that. And then there were discoveries in California and Australia in the late 1800s, and then discoveries in Alaska, Yukon of Canada, and South Africa in the early 1900s. So pure gold is too soft for prolonged handling, and usually it's used in an alloy with silver or copper or other metals. So we all know gold is very valuable. Here's the gold price. Right now, it's something on the order of $1,800 an ounce. So very nice. If you've got some gold, you've got some money. So properties of gold. Gold is completely recyclable. It is virtually immune to the effects of air, water, and oxygen. You'll have to polish your silver. You won't have to polish your gold. So its resistance to corrosion. It's the most non-reactive of all of the metals. It doesn't, we worry a lot about toxic metals getting into our system. Gold doesn't do that. It never reacts with oxygen, which is one of the most aggressive and active of the elements, which means it will never rust or tarnish. And it is very easy to work. Gold is the most ductile of all the metals, which means you can work it. You can beat it into sheets. You can make it into tiny wires, and it will hold together without breaking. It has a very remarkable material property. Now, platinum is often associated, thought about with gold. It is not very far away from gold. There's gold, and there's platinum right next to it. It has atomic number 78. And it also has a very high specific gravity, very dense. So, but in contrast to gold's, yellowish color, platinum is a silver white. It has a high melting point, whereas gold had a melting point around 1,000 degrees centigrade. Platinum doesn't melt until almost 1,800 degrees centigrade. But it is also very resistant to corrosion and chemical attack. And it's usually found as alloys of on the order of 80 to 90% purity in placer deposits, sometimes combined with arsenic and silver. And right now it's selling for about $1,000 an ounce. So placer deposits are river deposits. So these are sedimentary concentrations. So let's imagine we have a quartz vein here on this hill, and then, erosion carries little pieces of rock and gold down and eventually works into the river, and the river may transport it a little ways. And then these deposits here in the stream bed can contain placer deposits of gold. So here's a gold nugget from California. That's about an inch across. And here are placer diamonds from Namibia. They're actually mining diamonds from placer deposits in Namibia in Africa. So most placer gold occurs as grains the size of silt particles, which is called gold dust. So there's a whole culture about the miners and how they used gold dust in California when they didn't have coins or things to use. Sometimes the grains are larger than silt particles, and then they're called nuggets. And many other heavy durable minerals other than gold form placers, such as platinum, copper, tins, diamond, rubies, sapphires. The key thing is that they're resistant to corrosion and they're very dense, so they tend to lag behind in the sediments. So here's a nice photograph of placer gold mixed with quartz. Here's another one. You can see this pebble has been rounded and the gold has been sort of smoothed out. Here's another one that's nearly all gold. Now, this is one that you can see down at the Perot Museum of Nature and Science in Dallas. This is the Osrox gold nugget. It weighs 51.29 pounds. There's a dime for scale, a quarter. And just so you get an idea of what it's worth, so 51.3 times 16 ounce per pound, $1,850 an ounce. It's about $1.5 million. So one of the ways that the Inca described these metals, especially silver and gold, is they talked about the sweat of the sun being gold and tears of the moon being silver. And this reflects their spiritual perceptions of gold and silver. All right, so let's now talk about the pre-Columbian mining technologies. And that includes placer mining and hard rock mining. So placer mining in pre-Columbian times, they used something like panning, simply putting sediments into a pan, a clay or some kind of a pot, and working it around, losing the light particles and leaving the heavy ones behind, which tended to be gold and platinum. And sometimes they would use little riffles, which were stone or wood structures that would be constructed across the stream, which would collect the nuggets and grains carried by the water. They also did hard rock mining, and there were pre-Columbian hard rock mines in Mexico. These are some examples. And in the Andes. So in many parts of the world today, there are groups of people that are doing their own little mining. A lot of this in Africa. This is called artisanal mining. Artisanal is sort of associated with, handicrafts and things like that. this is brutal work, and very dangerous work because these mines could easily collapse on this. All right, so mining in pre-Columbian times involved extracting the ore, which was, today we extract ore with machines and dynamite and things like that, which weren't available. Back then, they would use it, extract it by splitting the rocks using fire. You can use fire by making a fire, heating up the rock, and then dousing it with water. And that rocks expand with heat and contract with cold, and that sometimes would make them split, and then you can take the piece out. And then with rock hammers, you can also work it, but it's very inefficient mining to do it that way. They would scrape the ores with horns or hot bones and carry it out in hide sacks. And the Spanish reports mentioned that there were Inca mines that extended down to 20 or 60 to 60 feet and were as long as 240 feet into the side of a mountain. The Incas controlled the mines and exploited them with a form of forced labor called the mita. So the mita was the idea that all males between 15 and 50 years old were required to participate and to do public service for the Inca, typically 2 months a year. Now, this method of forced labor, which was invented by the Incas, was adapted and enforced by the Spanish. We talk about the fact that slavery was an important part in the development of eastern part of South America and the Caribbean. It was not an important part of the Spanish possessions because they did it this way. But these ores that the pre-Columbians mined were copper, tin, silver, gold, and lead. All right, so here is copper mining in Mesoamerica. So here's Mexico, Guatemala, Honduras, El Salvador. And these are all of the deposits that are known in mines that were worked by the Aztecs and the tribes around that. And then these are the regions where the ores were worked into metalworking. And in the Andean, we've got both north areas and south areas. Here we have the northern area. So here is northern Peru and Ecuador and Colombia. And these are the mining districts in various places. I don't see the one. I don't see it. Oh, there we go. There's Cuervica. Next. And then in the south, there's more. And going down into Bolivia. Potosi is far in the south, but we're going to be talking about that in later. All right, so the pre-Columbian metalworking techniques included hammering and annealing, smelting, and we will have to talk about huayrachinas when we talk about smelting, melting and casting, bronze production, and sintering. So here we have hammering and annealing. So hammering involves shaping the metal without melting it. So gold is especially appropriate for this. 1 ounce of gold can be hammered into 100 square foot sheet, or can be drawn into a wire that's 5 miles long. It's extremely ductile, as we said. Annealing is a process where the metals aren't melted, but they're heated to make them easier to work. So you heat the material and then cool it very slowly and uniformly, and that will increase the ductility and lessens the possibility of breaking the metal. And sometimes this is called hot working too. So here's an example. This is a black stone that gold would be put in there and then hammered in to make a desired shape. And then here are some things, including fish hooks. And downstairs in the rock building, we have some gold fish hooks that were recovered by a benefactor from the headwaters of the Amazon, maybe 100 years ago. So here are examples of vessels that are shaped by hammering. So here's a silver effigy beaker. And this is a wooden model for a hammered cup. So you basically take the metal and then you start to work it by hammering it around something that provides a shape. Okay, now you get a better shape and you're starting to work the metal back. And then you try and tighten it in there. And then you can put it on a new form and get something that will have sort of a projection. And you just keep using forms and eventually you get the shape you want. So all done just by hitting it by experienced craftspeople. So smelting in pre-Columbian time. So these are huayrachinas. Here is an example. And here is a sketch from ancient times. And there's two people, three huayrachinas, and there's smoke coming out of two of them. These things are fire coming out, and then that's the metal coming out of the base. So basically you charge this cylinder with copper ore. In this case, it was copper carbonate. And so you have to convert this into, reduce it into metal. And you do this by heating and burning charcoal in a controlled, enclosed space so that oxygen can't get in. And so you can get this reaction. Carbon monoxide plus copper carbonate makes CO2 and copper metal. And that copper metal is what's flowing out of here in this case. Only the Incas used the huayrachinas for smelting ores. So it was an advanced technology. And when we talk about what happened after the Spanish got there, it will be, the huayrachinas will figure prominently, especially at the beginning. So here's a huayrachina. This is a researcher that went up into the Andes to see how people did it. And so these are sort of clay things. And here's a huayrachina. It's got these holes to let the fire. So all of this thing gets filled with charcoal and the metal ore, and then it starts burning, and then the copper comes out there. All right, so melting and casting. Once you have the metal, you can melt it, especially metals that melt at a relatively low temperature like gold or lead. You know, platinum requires too high of a temperature, but this is a Spanish depiction of axe blade casting as practiced in Mexico. So here you brought the copper to a melting temperature with a blow type. You just blow on the fire so that it gets hotter, and then that reaction we talked about will end up in the metal coming out there. You can see it's being poured into a form, which is going to be the form of an axe, like there. And here's another example, a black stone matrix, which is used to make gold ornaments by pouring gold in there. All right. Now, one of the most interesting techniques for melting, for working metals is called lost wax casting. So basically, it is a process where you make a rough form, and then you add wax to the form and in the shape of what you want it to look like. And then you stick little things in there so that the molten metal can get in there, and you turn it upside down. And so you pour the metal in, this is turned upside down and encased in a clay. And then you pour the metal in there, and these little things are to let the air get out, because if the air can't get out, then the metal can't fill the entire thing. And then after you've filled it up with the metal, you let it cool, and it comes out as that. Basically, the metal is being added to this rough form. And here's an example of a gold cast owl, which was done by the lost wax casting. And both the Aztecs and the Incas used this technique to make their things. Now, some of the most spectacular things, when the Spanish got there, they wanted a lot of gold and silver, and you'll hear about how they got that in the next lecture. But many of the things, the Incas and the Aztecs didn't just give the Spanish big bars of gold. What they gave them were things that we would recognize as priceless artifacts today. For example, this is the Muisca raft, which was made, what is that, on the order of 1,500 years ago, sometime in Colombia by the lost wax process. And this is basically talking about the ceremony of the legend of El Dorado. So this is the ceremony of investiture of the Muisca chief, which used to take place at Lake Guadavita in Colombia. And during this ritual, the person who was going to be the chief was covered in gold dust and then jumped into the lake. And then also lots of gold offerings and emeralds were given to the gods. And this was just a representation of that. So let's watch a 2.5-minute video about the Bogota Gold Museum in Colombia.
This is Colombia's golden treasure. Visitors who step inside the Museum of Gold in Bogota get to see more than 33,000 gold relics from the country's ancient cultures. This is the largest collection of pre-Columbian gold artifacts in the world.
We go back in time 2,000 years, and all through the conquest where the Europeans found these indigenous societies that used these metal artifacts, for example, to adorn their leaders.
For the past 80 years, Colombia's Bank of the Republic has preserved, cataloged, and exhibited these historical artifacts in the Colombian capital.
The different exhibits also celebrate Colombia's rich and diverse population that varied in tradition, language, and cultural backgrounds.
Depending on the geographical location, the communities in Colombia practiced different rituals, myths, and customs, reflected in the relics they left behind. One of the most famous pieces in the museum is connected to the legend of El Dorado. The Muisca raft, discovered in a cave outside of Bogota, is small in size but rich in history. The Muisca was one of 4 advanced civilizations in the Americas. The raft shows a ritual, the investiture of a new Muisca chief.
When the Spaniards arrived in Bogota, they found out about this ceremony, where the chief stood naked in the middle of the raft, covered in his gold ornaments, and throwing gold offerings into the lake.
Another special item is the Poporo Quimbaya that dates back to 300 AD. It was the first artifact acquired by the Bank of the Republic for the Gold Museum. The poporo, which is a device used in the chewing of sacred coca leaves, is now a national symbol.
These objects have become symbols for our country and elements of our identity. We are proud of our past that we wish to always see as golden, with the good and the bad, rich in diversity.
Around 500,000 visitors come to the Gold Museum each year, and 250 Colombian school children visit each day to learn about their heritage, a past rich in indigenous cultures. Michelle Begesi, GTN, Bogota, Colombia.
All right, we hope you enjoyed that video. Bronze is an alloy of copper, tin, arsenic, phosphorus, and small amounts of other elements. Bronzes are harder than brasses, but much softer than iron. So here we've got sort of a modern way of representing the hardness of a metal. So this is the Vickers diamond pyramid hardness test. Doesn't matter the exact, but this is obviously softer and this is harder. And you see here, this is a steel is, very hot, very hard, and depends on how much iron you put in there. It looks like, if you wanted the hardest steel, you'll add about 1% carbon, and that makes it harder, carbon steel. Now, this is arsenic bronzes and tin bronzes. So this is copper combined with either tin, that would be a tin bronze, or copper combined with arsenic, that would be an arsenic bronze. And you can see that these are much softer than steel, but that an arsenic bronze is about twice as hard as a tin bronze. So these bronzes are significantly harder than just pure copper. All right, so here are examples of pre-Columbian bronzes. Arsenic bronzes, the harder bronzes, were produced in the Andes by about 850 AD. Arsenic-bearing copper ores are very common in the region, and so smelting these made a very natural arsenic bronze. So there was a region in central Peru that was the production center of this alloy, with 24 furnaces have been discovered so far. Now, tin bronzes first appeared in southern Peru about 1000 AD, and both of the bronzes were produced at different times to use their slightly different properties. The establishment of the Inca Empire around AD 1500 spread the technology to make tin bronze into the north, into Ecuador and in Western Mexico. So the Aztecs were producing bronzes by about 1200 AD. All right. Now, the last thing we want to talk about is platinum gold sintering. So platinum has a very high melting temperature, 17, almost 1800 degrees centigrade, almost double that of gold. So you couldn't really reach those temperatures until the Industrial Revolution. It wasn't possible to reach them using any of the technologies that were available to the Incas or the Aztecs. Now, what we see these materials that are nevertheless made of gold and also of an alloy of gold and platinum. And that alloy wasn't made like other alloys, which are basically combining the two metals in the molten state, but by sintering, which sintering is a process of pressure and heat applied to the fine grains of platinum and gold, which makes them combine without melting them. And at the time that it was discovered in Latin America, it was a technique that was unknown in Europe. So that's a remarkable achievement that the Europeans hadn't accomplished by that time. So here we go. This is the chronology of metallurgy in the Andes. So 1500 to 200 BC, the earliest metals were used were the native copper and gold. Beginning about 200 AD to 1000, you start seeing the alloys appear, copper, arsenic, bronze being the one that really appears, and then the tin bronze around 850, and combinations of copper and silver by 1000. And by 1500, the copper tin bronze technology had spread throughout the Inca Empire. So this was a kind of material science that the pre-Columbian cultures were making progress. Now, one of the interesting features about this interaction between the Inca Empire down here and the Aztecs up here is a trade between the two. So around 650 AD, the Mesoamericans in there acquired the first metal objects through trading with Ecuador and Colombia via maritime, the boats going back and forth. And the trade in clamshells, called spondylus, was very active, and the Incas liked to use it for ritual practices. Here's a spondylus up here. The spondylus only lives in this warm waters off of Ecuador and farther north. So, Peru would send their metals north, and they'd get back these really interesting clam shells. So this is a spondylus. You can see it's a really very interesting clam with those spikes. Now, let's watch about 30 seconds from this video. All right, and so in Mesoamerica, the metallurgy started around 800, and similar techniques to Ecuador and Colombia. There was a lot of trade and interaction between them, and then there was a second period began 1200 and 1300, and then continued until the Spanish invasion with new techniques, and then the bronze technology was being used. So there was a particular interested in metal bells. Here are copper bells. Here's a copper axe. And that's it. Next time we will hear about what happened when the Spanish come knocking.